the new session. It's about smells. It's about code smells, or more generally we say software smells. Do you know about Jugaad? Have you heard about the word called Jugaad? No? It's okay because it's an Indian Hindi word, which means that it's an innovative fix or a simple workaround. Okay? Or workaround, or more formally, it's a kind of a hack. I mean, if you translate this word, then it's a kind of a hack. You just work around something to, achieve what you want to do, although it's not a permanent solution. Let me give you some examples. I mean, because it's not really, these words are not enough to give you the hint what I mean. So, yeah, I mean, some software engineer in India. So probably his gas runs out. So what he does is using iron. He's using iron to make a tea, basically. That's a jugaad. It's a temporary solution. It's supposed what he wants to just make a tea for a night. So doing that, and it's an innovative fix, right? It's very hot in India. I mean, even hotter than in Athens, most of the time of the year. So, and this poor guy don't have AC. So what he's doing, he has opened the motherboard and using fan directly to dissipate the heat. In fact, I used to have, when I was doing my master's, I used to have one desktop. There was a problem with that desktop. It has some earthing issues. So if I put that motherboard in the cabinet, it never used to start because of the improper earthing. So I used to pull out that motherboard and put it on the paper, newspaper, and just run like that. If I do that, then it will work. If I put it in the cabinet, it will not work. You have 2 rooms, but one cooler. That's really a jugaad. What if the clock is broken? It's still working. There is a lock. I just want to avoid, or the person just want to avoid another person or another thief who can take the car away. So just put a proper lock. Yes. So you saw some examples of jugaad. So in my opinion, smells are jugaads in software. So what I mean that they solve some problem, but introduces quality deficit. Although we can laugh on these things, but actually these are not proper solutions. These are somehow we are work around something to fix the current problem, but these are actually not proper solutions. So, and they cannot be a long-term solution. I mean, for a night, if you just want to make tea, then you can use iron, but using an iron for your normal preparing food is not really a good idea. So, in my opinion, smells are jugaad in software. However, there is a very big difference that we should be aware of, that jugaad solve a problem when the resources are restricted. So, for example, many times because the guy don't want to spend on the proper lock in the car, so he opted the another jugaad. he knew that I can fix it properly, but it will cost more. So in order to avoid that cost, he is going for the jugaad. But in smells, in the case of smells, many times smells occur because developers don't know about them. So there is a big difference about jugaads and smells, but still, I would say that we can compare jugaads with smells in software. Okay, so you get a hint what a smell looks like. So now let's come back to our pure technical stuff. So when we talk about smells, basically they are quality problems. And we will see shortly some examples. And we say these are quality problems, they impact certain quality attributes. Specifically, we are interested in smells that impact maintainability, because we are talking about maintainability from the beginning of the session. And there are smells at each granularity. So when we are talking about the code level issues, there are smells at that level, which we call implementation smells. There are problems or the quality problems at design granularity, which we call design smells. And there are quality issues at architectural granularity, which we call architectural smells. For example, if you have a long method in code, if you have a long method, then we say that's an implementation smell. If you have a class which is very big, say having 100 methods, then we say it's an insufficient modularization design smell. Another example for architecture smell is cyclic dependency. You have two components, and they depend on each other. We say it's a cyclically dependent on each other. That's an architectural smell. So it depends where and at which granularity you are looking. So smell may arise at any granularity, but for our convenience, we differentiate among them to understand them better. And why we classify them, because they differ in the scope and the impact that they make. The implementation smells, their impact is local. So if we refactor the implementation smell, the gain is small, but the risk is also small. You will not probably break anything else. In design, when we are talking about design, we are talking about classes, and when we refactor, say, a big class into, say, we split another class from a big class, then there are chances that you will break some of the clients of that class, because some clients might be using those methods which are actually now in the other class. So you need to fix those problems. So their effect is little wider, risk is also little higher, but their gain is also little higher. Sorry. So what I mean is that at the implementation granularity, the gain is smaller, but the risk is also smaller. At the design granularity, the risk is little higher, and the gain is also higher. At the architectural granularity, the risk is even higher, because not only you, but many, for example, if you are working in a distributed team, so part of your team is working from Athens, for example, part of your team working from Germany or say US or from India. So if you break a component, then there might be other teams that might get affected. So there is a risk, but the gain is also very high. So in general, we say that higher the risk, higher the gain. So that principle applies here. Okay, that's why we study these granularities. Yes, please.
Is refactoring a standard stage of software development?
Is refactoring standard?
Standard stage.
No, actually, there are some discussions or debates that whether there is a dedicated stage for refactoring, but in general, specifically in agile methodology, if you are following agile, then there is an emphasis on refactoring, but there is no dedicated time slot for refactoring. I mean, in some cases, what happens is when your smells grows and your technical debt, what we say, it's a technical debt becomes very huge. Some cases we can take refactoring sprints. We call it refactoring sprints. We only perform refactoring in those sprints, in those stages. But those are very debatable. Typically, as we go, whenever we see something is not right, we should refactor. That is called Boy Scout rule. What it means is the scout, the people who, or a group of people, when they go to for example, to a site, for example, a jungle. So there is a rule for them. When they arrive there, whatever the cleanliness or whatever the stage of that particular place where they are staying in jungle, when they leave, they're supposed to leave that particular place cleaner than what they got. It's not that they keep littering here and there, they spill coffee, water, or they just dump their garbage there. They're not supposed to do that. That's called Boy Scout rule. So the same rule applies in software development. When you work as a developer on some class, when you start working, for example, if you are fixing a bug, then obviously you have to fix the bug, but also you need to see if you can refactor something. If you spot something, you refactor, you test, and you are done. You leave that class in much better state than you got the situation in which you got.
So it's more on demand.
Yes, and typically refactoring happens when you are extending the system. So when you try to extend the system, and then you see, okay, for extending the system, first you need to make some arrangements so that this system can take up a new functionality. So typically it happens like that. But in general, we always recommend that whenever you see something, especially in the smaller side, especially if you are working in a class and you anyway have to test it because you are working in that class, maybe you are fixing some bug or you are extending that class. So anyway, you have to test it. So when you are working on the class, you try to refactor as much you can do. That's Boy Scout rule. So this is some examples of implementation smells. First one, long method. So if a method you wrote is, say, for example, 100 lines of code, that's considered a long method. Right? So try to avoid these kind of smells, especially, and right now I'm talking about implementation smells, which means that smells that have low risk, low gain. Complex method. Complex method in the sense when the cyclomatic complexity, we have just seen in the last session, right? What is cyclomatic complexity? Okay, let me ask. What is cyclomatic complexity? Yes, you know. Please.
The different paths the code can take.
Different paths, independent paths that a method can take. Okay? So you need to compute the permutations, how many paths, independent paths the method has. That's the number of paths equal to cyclomatic complexity. Okay? Anybody has any doubt about cyclomatic complexity? Should I ask another question on cyclomatic complexity? Let me ask, No, not you. Don't worry. Yes, sir.
Me?
Yes.
What do you want?
What is cyclomatic?
What do you want to know?
What is cyclomatic?
How many linearly independent paths exist in our code?
Okay, in a method. Okay.
In a method. Okay.
Yes. And let me ask somebody else. Can you please answer? Why cyclomatic complexity is important?
What?
Why cyclomatic complexity is important? Why we are measuring that?
Because we want the method to be as similar as possible.
That's one reason, yes. And what is the implication if, for example, if cyclomatic complexity is 10 for a method, what is the implication? Let him answer.
It will be needed 10 tests to the specific.
Minimum 10 tests. Okay? So if the cyclomatic CC is 10, which means we need minimum 10 tests to cover all paths. There might be many tests because we don't normally write one test for one method, we write many tests because the one for border conditions and normal conditions and lower border and higher border, and there could be many cases. So that's why we say minimum.
So we will need at least 20.
Minimum is 10, it can go upwards, any number, depending on what this method does. Yes. So this cyclomatic complexity we use in complex method. So if cyclomatic complexity is above certain threshold, we say the method is complex. Okay? Long parameter list. It's very obvious that you have a method and you have a parameter list. If you have so many parameters, say more than 5 parameters, then we say that it's too much. Maybe if these parameters are used together and changed together, then probably we need to make a abstraction out of them and put all those parameters in a class and pass the object of that class, rather than passing 5 or 10 parameters. Long identifier. An identifier which means like a variable name. So if you have variable name which is very long, then you will be straining yourself, what is this? Maybe it's a whole sentence. I mean, it looks silly right now, but many people write very long variable names. Yes?
Sometimes we cannot avoid that. For example, query methods.
Yes, I mean, but it's up to you. It's up to you. I mean, if you think that the longer name is giving meaningful because you want to keep it meaningful, it's okay. You can keep it, but don't unnecessarily make it very long. For example, you can use NO for number. So if you use number of something, rather than you can just say NO, or you can use count. So, for example, if you are writing a variable name, say number of namespaces, so you can write number NUMBER of namespace. You can write that, or you can write NO namespace. That is another possible variable name which is giving the meaningful. It's still meaningful, or you can just say namespace count. It's still capturing the same meaning. So you need to give your variable name a meaningful name, but still try to avoid very long identifier name. Yes, please ask what's
For example, in the JDA framework, we have to use big names for methods.
I was emphasizing the fact that these are indicators. These are not absolute rules. Okay?
Yeah.
So if you have to use it, you have to use it. It's okay. Nobody is saying that you cannot have a long identifier. Nobody is saying that.
Yeah.
It's just an indication that you might be creating some maintainability issue. But if you think that this long name is okay, justified in your situation, it's okay. Okay. Long statement. Try to avoid long statement. At least each statement should fit in your screen. If a statement is not fitting in your one row and crossing like you have to scroll horizontally, then which means that it's not really a good practice, and we should avoid that. Consider splitting it into two statements or even three. Complex conditional in the sense if you have a, say for example, if condition, and then you are checking many conditions in that. So if you have one condition, then and then another condition, then or, and then another condition, then another logical operator, and so on and so forth. So you should avoid that long chain. If you have that, if you have to check for some certain condition, then try to encapsulate that in a method. Or even better, you try to split it into multiple more meaningful expressions, so that you know, and it will be helpful for you in debugging also. So you can check what is the value is coming for a sub-expression, and then you can check those values, and then you can, if there is any problem or any bug, then you can debug it much better. And it's also when you are reading it, it's much better to understand, okay, this is what you are trying to do. If you have, say, 7 different conditions in a one if condition, and you have a lot of logical operators, then it's a difficult time for you, especially if there is any bug. If you don't know why it's not going in that if block, then you need to see each and individual element. Better to just split that conditional into sub-expressions. Empty catch block, it's very common smell. So you write a try block, and then you catch. In the catch, there is nothing. Yes, I mean, it's okay if you are writing a small application just for trying something, but it is not.
Trace isn't.
Yeah, I mean, you can. If that is the case, if you are using some IDE, so IDE is doing okay. At least you print this trace. But okay, that's the minimum. What you should do minimum is that at least you should log that exception. If you are using any logging mechanism, then you at least log that, and if possible, try to overcome that exception. Obviously, it depends on the where the exception is occurring, whether it's recoverable or not, and many more such factors. But at least don't leave that exception, catch that exception, and don't do anything. That's normally not considered a good practice. The next one is magic numbers. Magic numbers are like that if you have an expression, say, if variable name equal to 1.1415 something. And when you are writing the code, probably you know what you are writing. But when you are debugging it, then you scratch your head and what this number means. Why I am comparing this to this number. Right? So, yeah.
It's the same flags.
Yes.
But
Yes, in general, avoid flags, or if you have flag, then give a proper meaningful name. So giving meaningful name, if you write meaningful names, half of your comprehension problems are solved. So give a meaningful name. In this case, magic number, the better practice is that obviously you have to compare with a certain number. So declare it as a constant and give it a proper name. So you know, okay, this is the value of pi, for example, or some other constant. So you read that and you understand, okay, it's a constant which I have defined in the top of the file, for example, or in a constant file, something like that. Duplicate code. Duplicate code in the sense you have a method, say 10 lines of block that you have in in one place and you copied the same thing somewhere else. And it is not really desirable to have duplicate code. Can anybody tell why? Yes?
Because you can use the first code snippet and not rewrite it.
Anybody else? Yes.
If you need to change something, you have to remember that it's duplicated.
Yes, and that's brilliant. Actually, that's precisely is the problem. So one reason is yes. I mean, you have to deal with same block multiple times, and you see same block multiple times. That's not really good for your memory or comprehension. Another very big reason is that, for example, if that block has some bug and you have to change it, and probably when you are writing, probably you know that there are two copies, but when you will fix the bug, say 6 months later, you don't remember that how many times you copied this. So you probably fix at one location, and if you are aware, then probably you fix at another location, but it is very likely that you will miss something somewhere, some location which you copied but you don't remember it. So the problem, the bug that you discover that you are fixing is fixed in one case or one location, but not in another location. So your code will become behave very weirdly. Sometimes it will show it is fixed, sometimes it will show it's not fixed. So better to try to avoid these duplicate code. Any question on this? Do you have you seen such kind of problems in your code?
Yeah, many of them.
Believe me, it's any software system that you take, these problems will be there in all the software. The only difference is that how many of them you detect that. So your goal is not to reduce these numbers to 0. That's not your goal. Your goal is to keep these numbers minimum, because anything you do, for example, if you want to refactor, it will require some effort. And not only just to fix that particular piece, but you need to test it also, right? I mean, you need to make sure that when you change anything, things work as it was working earlier. So there is an effort involved. So if you keep refactoring small things, then and don't do any other meaningful thing, then your manager will come and say, what you are doing. So that's probably not the best way to go forward. The best way forward is that whenever we work on something, we try to refactor as much as we can do, and we also do some meaningful to the manager or meaningful to the client. And this is meaningful for you as a developer. Okay? These are some of the cases of implementation smells. Now we will discuss about some of the cases where design smells may occur. So when we talk about design smells, this is what we produced, and I was fortunate to co-author this work. So we produced this classification of design smells. So earlier there was many smells which may occur in design, but there was no comprehensive catalog. So we prepared this catalog and we prepared this classification. There are all the smells. There are 25 smells. All the smells are classified based on the principle they awarded. So there are 4 principles: abstraction, encapsulation, modularization, and hierarchy. And there are total 25 smells categorized in these 4 categories. So I will only show a few examples to just give you a sample of what a design smell may look like. Look at this. So you have a class called device, another class called device data. You can see there are some methods in this and there are some attributes in device data. Do you see anything wrong with this? Or this looks okay? And don't look at the small, implementation level. Anyway, there is no information on how it is implemented. Showing the diagram so that you can think in terms of design. Any observation? Yes, please.
The device data class has no methods.
Yes. Anybody else?
Device data could be incorporated into the device
Yes. And why so?
to keep it simple, to keep it all organized in one single class.
Very good. Very brilliant answer, and this is what I was looking for. See, in object-oriented design, in object-oriented development, software development, we encapsulate data and behavior in a single entity called class. We encapsulate data as well as behavior, which the behavior will work on or which manipulate these data members. So the data members and behavior or the functions must be together in a single entity, and that entity we call it class, right? And when we design something like this, when we have a class only with methods and there is another class which only have data members, we basically split these two things in two classes. Then what is the point in having a class? It's very similar to like a C program which is just listing all the methods. So there is no real advantage that we are gaining from having an object-oriented design. So essentially, the device data is supposed to be manipulated only by the methods provided in device class. So why to split in two places and have two separate entities? We should keep it together so that the related things are put together. This is what we call broken modularization, and this smell arises when the members of an abstraction are broken and spread across multiple abstractions, when ideally they are supposed to belong to a single abstraction. So there are two cases possible here. So the one case I just shown here to you, that there is device data and device class, and the behavior is separated from the data. That is one case. Another case that may happen here is that you have one device class, but half of the methods and half of the data members are in one class, and rest of the methods and rest of the data members are in some other class. So they will be showing high coupling because they are related. So in both the classes, since both the classes are related to device, so they will most likely will be calling each other, and they will be showing high coupling. So why don't we put together in a single class? Because they are dealing with a single entity, single abstraction. So that's called broken modularization, design smell. This is another example. I'm showing a component class. This component class is from Java JDK. If I'm not sure whether you have seen it or used it. This component class has 107 attributes or fields and 259 methods and more than 10,000 lines of code. In Java SDK, you can still go and see. What is the problem with this? If it's not obvious yet. Anybody? Yes?
It's huge.
Yes, it is huge. In terms of number of methods, in terms of lines of code, it is huge. So that whenever we see something like this, we say it's insufficient modularization design smell. Some people call it God class. Okay, if you look it on the internet, many people refer these kind of problems as God class, which has a high number of methods or very huge in terms of lines of code. So this is how we define it, that when an abstraction exists, that has not been completely decomposed, and a further decomposition could reduce its size or complexity or both. So basically we can decompose that class furthermore. If that is possible to reduce the size or complexity, then we say that that class is suffering from insufficient modularization design smells. Okay? Another example? This is again an example from Java SDK. Very popular actually. Vector and stack. What is the problem here? It's a very interesting one. Yes?
Stack is more abstract than vector.
Okay, I know you know. It's okay. Yes, please.
Vector works with synchronization.
No, not that. That's not probably the problem here. Any other problem that you spot here? Okay. Yeah, you have any answer? Any thoughts?
I cannot understand the shape.
Oh, okay. By the way, vector is what is vector? Anybody know vector? Yes.
It's a way to store data in the
Exactly. So it's basically an array. So that's a vector. So vector is basically an array. Everyone understand array, right? And stack is a stack which is a leaf or list, a last and first arc. Everyone understand stack? Yes, no? Yes. So array is, what is the characteristic of an array? So you can access any element of the array given an index. If you have an index, you can just say, give me 5th element, give me 10th element. And you can access any element in the array with using the index. That's a random access basically. What is the property of stack? Last in, first out. So whatever the element that you have put last, that element you can retrieve. Okay? So you can't access any element from that list. That stack may have many elements, but you can access only the top element which you inserted last. Okay? That's LIFO, last in, first out. And since they are in a same hierarchy, what is the implication? The implication is that we all know that the subclass inherits all the public methods of the superclass. Yes? And vector class has methods like give me this number in this element given the index. Right? So that method is inherited by stack. So now if I have a stack object, then what I can do? I have a stack object and I say, okay, get me this element. Get me 5th element.
Okay.
And it will be successful because it is implemented in the superclass. It's supposed to not happen, right? Because it's a semantic mistake. You have the stack object and you're supposed to not access the other elements other than the last element. But if you by design, if you are allowing your users to access any element, which is a big mistake. Yes, please.
Yeah, but in the vector, it doesn't really include stack objects inside, so we have to do get whatever to get the stack and then get another one to get the proper value from the stack. It's like a nested thing, no?
No, I'm not talking about, I have another class. So for example, I have another, say, program class, and I declare stack object.
Yeah, maybe I don't understand the error. Does that mean that the vector contains stacks inside?
No,
Ah,
this means inheritance.
okay.
This means inheritance. So vector is a superclass and stack is a subclass. Okay. So everyone understand the problem what I just explained, or should I repeat it? You were asking something?
Yes, it would be a better implementation if they have made the stack object that is a wrapper for a vector, a wrap.
Yes. Okay.
You have a field of
what-
vector, and you have only the method that you want to pass to the vector, the actual what you will use.
Okay. Yes. Why this happened possibly is because the developer of stack probably wanted to reuse some of the methods from the vector. A better way to reuse is that you use, this is a relationship. Inheritance always is a relationship. Another relationship that could be like has a relationship, which is the aggregation. So if you are in this same situation when you want to reuse some of the methods which are defined in some class, and when is not a good solution, then you can implement using has a. So stack could have a reference to vector, aggregation relationship, not inheritance relationship, and still could have been used vector inside the implementation of stack. And that way this problem could have been avoided. Okay? Any other question or doubt, or if you have not understood this? Okay. This is what we call broken hierarchy, and broken hierarchy happens when superclass and subclass don't share is a relationship. Let's take a look at another example. Although it's a Java, but I guess you can also understand what it means. Anybody would like to tell from the Java side what this print stack trace does? What this print stack trace does?
It prints the stack trace.
Where?
The error
Where?
in the console.
Okay, so it's very simple actually. Why everybody is not answering? Anyway, yes, it's a printing stack trace. It's straightforward on the error, standard error. It's printing. What is the problem is that if you are writing a Java application and you are using, for example, in some exceptional cases, you also want to catch that string and probably put in something like a log so that you can analyze later what happened and why it happened and for debugging purposes. But the problem is that it's a string. So what you need to do is, if you want to understand in which method it occurred, or what is the exception, the message of the exception, then you need to do a lot of regular expression parsing. So you need to, you have a string and then you parse, okay, this is the method, then you parse this part and then you put in one part, and then you also use another regular expression to parse the message of the exception, and then you log it. And what will happen if Oracle changes the syntax of this string? If the syntax of the string is changed, then all the programs in the world which are using this print stack trace and they are logging somewhere and using regular expression, they will all break because the syntax is changed. So for example, earlier the method name was coming first and then exception is coming later, and now the exception is coming first and method name is coming later, or something else is introduced in between. if the syntax is changed, all your regular expression will break. In that case, that's a problem for all of you, right? So that's a problem, and then this problem is being identified in Java 4, and they refactored this. And what they did is they introduced a new abstraction, and now if you call that method, okay, I don't really have that refactor version. So in that method, if you call the other method, then you will get an object and not the string. And now, since you are getting an object, you can call that, okay, this object exception dot method. So it will give you the method, or exception dot message, exception message, you will get a message, and so on and so forth. So you are not depending on the syntax of the string. So the lot of information was encoded in the string. Lot of information was encoded in the string that you were decoding using level expressions. Now you just have a method object, and that object you can just use the methods of the object to get the required information.
But they have also kept the old implementation.
Yes, they still have this because of the
they
backward
don't break
compatibility. Backward compatibility. So they are not, you can still use it, but there is another way to do it much better. This is called missing abstraction. So this happens when you use strings to encode lot of information in a single string. So when the clumps of data or encoded strings are used instead of creating a class. Another example would be if you have an ISBN number. So if your software is dealing with the books and you have ISBN number, the ISBN number, if you are keeping as a string, that could be the first choice. But this ISBN number has many parts of information. For example, who is the publisher, who is the author, what is the title of the book. And all this information is embedded in the ISBN. So if you are writing a software which involves ISBN, so you have to take out the relevant information very frequently. So you might be, whenever you need the publisher, so you might be saying, okay, from 7 and 9 digits, you extract those digits, and then you interpret what these digits refers to which publisher, and then you use the name of the publisher in your code. And if you are keep doing it multiple times in the code, think about it, that how clumsy your code will be. Instead, if you have an ISBN class and you expose those methods that, okay, get publisher name, get title, get author, whatever. So you have to implement that logic only in that one class, and you can just say, okay, ISBN.get title, and you will get the title. You don't have to bother about those decoding the specific digits in the ISBN number and then referring which class or which book this digit refers to. Is it making sense? Yes? No? Yes. Okay. So that's it. These are the examples that I have. Now what I will do is I will give you a demo of a tool called DesignNet, and it has things that you can compute matrix, you can detect implementation smells that we discussed today, you can detect design smells that we discussed today, and many more things. And I will show you how it works now. Okay?